Good morning, friends. So today we will see a method which is called as a branch current method, which is used to determine the response of the circuit. Means we have to calculate a current flowing through a particular resistance. So in a given problem, let us define the problem statement like this one. Calculate the current flowing through 10 ohm resistance using branch current method. So if you look at the circuit, then circuit consists of 1, 2, 3, 4, 5 resistances, one battery of voltage 10 volt, and one current source having value 2 ampere with the shown direction. So for solving such problems using a branch current method, we have to use the concept of source transformation. That means if one source, say a current source is there having a resistance in parallel, then that current source we have to convert it into equivalent voltage source. See here, the current source is of value 2 ampere and 12 ohm resistance is in parallel. So if I place this point as say X and here Y, so to the left of point X and Y, I have a current source in parallel with a resistance. So I will convert that into equivalent voltage source. The procedure is, whatever magnitude of the voltage source is there, that magnitude is current source multiplied by a resistance. And for a potential source, for a battery, the polarity of the battery is, if the current is flowing upward, then upper terminal of the battery is positive. Okay, that means whatever the battery is there, now battery potential is 2 into 12, that is 24 volt, and the resistance which was in parallel, now that resistance comes in series. That means here you have 12 ohm resistance. Now what are these 2 points are there? Those 2 points are same. So here point is X, here point is Y. Now what are the remaining circuitry is there? I will just reconnect the remaining components. Okay, so this is 8 ohm, this is 2 ohm, this is 10 ohm, 5 ohm and 10 volt. Now if you look at the circuit, now this circuit is having 2 distinguished loops. So I will mark this as loop 1, this as loop 2. Now in case of branch current method, we have to use KVL, that is Kirchhoff's voltage law. Now when I am adding the potentials, I have to decide some direction. So here I will take the direction clockwise for loop 1, again clockwise for loop 2. The point to be noted in case of branch current method is, we are not assigning the loop currents, rather just we have assigned the loop direction. How to assign a branch currents? Okay, and once again when I am taking number of unknowns, the condition is number of unknowns for the current must be equal to number of loops. So if I start with say this as I1, the current that is delivered by the battery. Now this current is coming up to this point. Now I'll just remove this X and Y, we don't need this. Here if I place a point X, node X, then this I1 current is coming up to node X, and afterwards current is flowing here and current is flowing here. Now since we have to calculate current flowing through 10 ohm, I will assume the one variable here I2. That is current flowing through 10 ohm is I2. So what are the remaining current is there? That current is I1 minus I2. That is flowing like this way. Again for simplicity, for understanding, we will assign the voltage drops. So when current is flowing from left to right through 12 ohm, the potential is plus minus. Similarly this potential is plus minus. Now current is flowing downward, so the potential is plus minus. Current is flowing from left to right, potential is plus minus, here also plus minus. Okay, so these are the various currents that we have, currents and the voltage drops that we have assigned. Now my task is just to apply the KVL. So what I am doing is applying KVL to loop 1. So when I am applying KVL, I have to start from some point, traverse in a clockwise direction, when I'm traversing in a clockwise direction, again I have to come at the same point. Okay, so this will complete a loop. And when I'm adding the potentials, once again, whenever there is a rise in potential like minus to plus, I will take the drop as positive. And whenever there is fall in potential plus to minus, I will take the drop as negative. Okay, so with this one, you have the first term 24. Now the minus 12 I1 minus 8 I1. Now I will go downward. Now through this one, current is I2, so once again current is flowing down, so it is minus 10 I2, that is equal to 0. So this is the equation after applying KVL to the loop 1. So if you simplify, this comes minus 12 I1 minus 8 I1, so it is minus 20 I1 minus 10 I2, that is equal to minus 24. Now since everywhere there is negative sign, I can make the signs like this one, and I will take this to be equation number 1. Now if I apply KVL to loop 2, so again I will start from some point and I will traverse in a clockwise direction. Look here, now what are the potential is there across 10 volt, that is from minus to plus when we are applying KVL to loop 2. The same potential when we are applying KVL to loop 1 is plus to minus. Okay, so there is the change in the polarity. Okay, now the potential comes to be 10 I2. Now here it is plus to minus, so the potential drop is minus 2 I1 minus I2 minus 5 I1 minus I2, and this drop is plus to minus. That means once again there is a fall in potential, and that fall in potential will take as negative, so minus 10, that is equal to 0. So if we simplify this equation, minus 2 I1 and minus 5 I1, that brings minus 7 I1. So here it is plus 2 I2, here it is plus 5 I2, that brings plus 7 I2. What are the minus 10 is there? If I take that minus 10 on right side, then it is plus 10. So this is equation number 2. So we'll check. This is 10 I2. It is 2 I2, 12 I2 plus 5. It is 17. Just have a correction there. So your I2 term is 17 I2. 10 plus 2 plus 5. That is 17 I2. For I1 it is minus 2 I1 and here minus 5 I1. So it is minus 7 I1. So now you have two equations, equation number 1 and 2, in terms of two unknowns I1 and I2. Now since my question is to determine current flowing through 10 ohm, and current flowing through 10 ohm is nothing but I2. So ultimately equations 1 and 2 are how to solve for I2. Now to solve these two simultaneous equations, what you can use is the Cramer's rule, or you can use direct calculator. So if I solve these two equations, my final answer comes to be 0.897 ampere. Okay, so this is the value of I2, and this I2 is nothing but your I10 ohm. So very quickly, if we recall the procedure of solving a particular circuit which includes current source in parallel with resistance is, first make use of source transformation theorem. Now that theorem states us, whenever there is current source like this one in parallel with resistance, then we have to convert that into equivalent voltage source. Magnitude of the voltage source is current multiplied by resistance which was in parallel. So here 2 into 12, that comes to be 24 volt. And the resistance which was in parallel, now this resistance comes in series. So what are the given circuit is there? This circuit we have converted into the next one, which circuit? That circuit includes only voltage sources. The point to be remembered is, if I want to analyze the circuit using mesh analysis or branch current method, it is preferable to have voltage sources rather than current sources. The next step that we have followed is for the second circuit, a modified circuit, we have applied KVL to the loop 1. We got one equation. We have applied KVL to the second loop. We got another equation. And in the last step, we have solved these two simultaneous equations. Now, since the question is to find out current flowing through 10 ohm, if I look at the current assignments, current flowing through 10 is assigned as I2. So what is the I2 is there? This I2 comes to be 0.897 ampere. So the final answer of this particular problem is current flowing through 10 ohm is 0.897 ampere. Thank you.